Okay, in this video I'm going to continue on with exercise 4b of the book Fundamental Applied Mathematics. We're on page 104 and the question is 9. It reads, a river is 120 meters wide and flows 7 meters parallel to its straight banks. A speedboat can travel at 25 meters per second in still water. If the speedboat can go straight across the river, find the angle at which the velocity relative to the river makes with the bank and the time taken to cross the river. Okay, so the first thing we're going to do is sketch the motion. We draw our x-axis and we draw our y-axis, making an xy plane or our Cartesian plane. I'm going to draw in dashed red the other side of the bank and say that the x-axis is one side of the bank. So we know that the velocity of the water is 7 meters per second. I'm going to say it's going this direction, so this is VW, whose magnitude is equal to 7. The next thing we're told is that the boat has to go straight across the river. So if you're in a helicopter above the river, you would see the boat go straight across like so. So this is I'm going to say VB, the velocity of the boat. Alright? Now the next thing is we need to work out where the boat actually aims, or where does he head. Like I said, he actually wants to physically go straight across, but since the current is going to the right, he will have to aim somewhere up and left like this in order to go straight across. Alright, so the question is this, is that which relative velocity vector is that? Is it VBW or is it VWB? Now just to remember what these mean. This means here is the velocity of the boat relative to the water, whereby the water is in a frame of reference whereby it believes that it is stationary. Similarly, in this case, the boat believes that it is in a stationary frame of reference. Okay? So which case fits the information we're given? We're told the speedboat can go straight across, or it can go, 25 meters per second in still water. So where the water is in a frame of reference that it's stationary, we have 25 meters per second equal to VBW. Alright, now just to prove that we're talking about VBW, so VBW is mathematically quite simple. It's VB minus VW. Now what happens if VW was 0? Well, then VB would be equal to VBW, and the boat will go straight across the river in this case. Alright, so we're actually dealing with VBW. Alright, now the direction it's going we know, because it has to go against the current, we'll say, or into the current. And I'm going to call this angle here theta. So if we resolve the vector VBW, this is VBW here, it's going to be VBW is equal to negative VBW sub x I hat positive VBW sub y j hat. Alright, because of course it's in the second quadrant. So that's just going to be equal to negative VBW times the cos of theta, and this is going to be plus VBW times the sine of theta j, and that's going to be equal to VBW. Alright, now is there anything else which we know? First of all, we know that VB is equal to x, or we'll say, 0 I hat plus x j hat. That's the first thing we know. And what about the velocity of the river? We know that the velocity of the river is equal to 7 I hat plus 0 j hat, because it's going parallel to the x-axis or the I hat unit vector direction. So I'm just going to write these again here, just for clarity. When I say x, I mean that it's unknown at the moment. X is just a variable that I'm going to use. Alright, so now with all this information here, we should be able to work out something. Alright, so we know, of course, the magnitude of VBW is equal to 25, because we're given that. That's how fast it can go in still water. Alright, so let's just put all these three pieces of information into this equation here and see what we get. So we get negative 25 cos theta I hat plus 25 times the sine of theta j is equal to VB, which is, we'll say, x j hat, minus, and we got to take away from that VW, which is 7 I hat. So therefore, we know of course that, plus, one second, xi hat plus 0 j hat. Just let me write this in properly. Xi hat plus 0 j hat, take away from that 7i hat. Oh, that's the wrong way around, excuse me. It's 0i hat plus x j hat minus 7i hat plus 0 j hat. Alright, now we know of course that the I hat components will all add together. So we know that minus 25 times the cos of theta is equal to 0 minus 7. Alright, and therefore cos theta is equal to negative 7 over 25. Therefore theta is equal to the inverse cos of negative 7 over 25. Alright, so let's just plug that into our calculator. Shift cos for inverse cos, negative 7 divided by 25, and we get an angle of 106 degrees. Okay, 106 degrees for cos theta. Now, what does that mean? Now, if you just look at it, by the way, because we're using negative 7 there, the angle which we just got was actually this one here. So, we'll say obviously if you take what we just got, 106, take that away from 180, and you'll get what theta is. 73.73 degrees. Okay, so theta is equal to 73 degrees. Or we'll call it 74 degrees. Theta is equal to 74 degrees. Alright, so let's just get rid of these pieces of information which we don't need. Now if you go back up here, that means of course that 25 times the sine of 74 is equal to x, just equal to x plus 0. So therefore x is equal to the sine of the answer multiplied by 25, giving us 24. Alright, 24. Now which direction is it going in? It's going in the j hat direction, so x equal to 24 j hat. And we're asked to find the angle which the velocity relative to the river makes with the bank. So let's just first find out if our answer was correct. So it's 4b question 9, 73.44, yeah, that was correct. And also we're asked to find how long it will take to get across the river. Alright, so the river we're given is 120 meters wide. Alright, so just bear with me now and we'll see what we have here. So we know that VB is equal to 24 j hat plus 0 I hat. And we know the river is equal to 120 meters. Now in order to cover distance in the j hat direction, you need a speed in the j hat direction. So our speed here is 24, so we're just dividing 120 by 24, and we're going to get an answer of 5 seconds. Alright, so let's just see if that's correct. 4b question 9, 5 seconds. Yes, that is correct. So that was pretty straightforward. Thanks for watching. Please pass it on to your friends and subscribe to my channel.